Elimination is another type of method for solving systems of equations. Now, in our book, it's called the addition method, but really it's just adding the two equations together in order to eliminate one of the variables, either x or y. Okay? So, let's look at an example of how elimination works. If I have 2x minus y equals 7 and 3x plus y equals 3, okay? Now, when we are looking at eliminating, we want the number in front to be opposite and the same number. So for instance, here I have 2x and 3x. They're not the same number. So I don't want to eliminate x at this point because it's not easy, okay? But if you look here, I have a negative 1y and a positive 1y. Negative 1, positive 1, add them together becomes 0. I can eliminate my y's right here by adding the two equations together. So I add, and I get 2 plus 3 is 5x. These y's eliminate, okay, and that equals 7 plus 3, which is 10. Now I divide by 5, so my x becomes 2. Now, like we did with substitution, we have to take this x and plug it back into one of the equations, okay? Now, when you hear me talk about these, you will hear me say the original equation, because eventually we may have to do some multiplication or division in order, well, multiplication, in order to eliminate, okay? So when I say original equation, that means before we do anything to the equations, okay? So, I have x, I need y. Again, it doesn't matter which equation we use. Both are in standard form, so it just doesn't matter which one I use. So let's take the first one. We plug x in, so 2 times 2 minus y equals 7. 2 times 2 is 4, minus y equals 7. So I need to subtract my 4. So this becomes negative y equals 3. Now, I have a negative y. I need a positive y. A couple of ways we can do this. We can multiply by negative 1. That'll change my signs. Okay? Or you can just say, okay, I've got negative y, positive 3, change this sign, I change that sign. Done. Okay? So my coordinate is 2, comma, negative 3. Okay? So that is the basic elimination type of method, where you have one variable with the same number in front, opposite signs, you just add your two equations, okay? That is the simplest form of elimination for solving systems, okay? Now, next. The next simplest one, go back up to the top here, example 2. Okay, this particular problem, I don't have the same numbers in front of either x or y. However, I have one negative, one positive in front of the y's. So I can eliminate the y's a lot faster than the x's. However, I need to change my numbers so they're the same, okay? So I have 4x plus y, x minus 2y. I need a 2y. So in order to get that 2y, I need to multiply my top equation by 2, okay? So let's do that. 4 times 2 is 8. 2 times y is 2y. 2 times 3 is 6. Okay? There is our equation changed. Again, when we plug back in, we're going to go into the original equation. Okay? So here we are. I can now add these two equations together. 1x plus 8x is 9x. Negative 2y plus 2y, they eliminate, leaving 0 there, and then 3 plus 6 is 9. Divide by 9, my x is 1. Okay? Now take this 1 and plug it back up into one of those two equations. Okay? So let's use the top one, 4x plus y equals 3. 4x plus y equals 3. Put the x in. 4 times 1 plus y equals 3. So 4 plus y equals 3. Subtract your 4. You get y is negative 1. So this coordinate is 1, negative 1. Okay? And that's the final answer. So again, the simplest equations have the same number, opposite signs in front of one of the variables. In this case, I used y a lot. It could happen in front of the x too. So look at the problem carefully. Don't just dive in and start. Look at your problem. Look at what numbers are in front of the x's, what numbers are in front of the y's. Where are the signs? Okay? A couple more examples. Okay, in this case, I have all positives. So I could eliminate the x or the y. It doesn't matter which. However, looking at this carefully, I see I have 3 and 5. I have to multiply them to get the same number. So that would be 3 times 5 is 15. So I would have to multiply this one by 5, this one by 3, all the way through. And one of them has to be negative then at that point. A lot of hassle, a lot of work. We all know we don't want to do a lot of work. So let's look at what's in front of y. I have a 4y, I have a 2y. 2 is a factor of 4. 4 is twice 2. So, here we go. Let's use the y's to eliminate. I need to multiply this one by 2 to make it look like a 4. But I also need a negative. So let's multiply the entire equation by negative 2. So I get 3x, whoops, let's save that one. Negative 2 times 5 is negative 10x. Negative 2 times 2y is negative 4y. And negative 2 times 5 is 10. All right, I'm going to bring the original equation underneath this one. 3x plus 4y equals 11. Now I'm going to perform my elimination. Negative 10 plus 3 is negative 7. The y's eliminate. And 10 plus 11 is 21. Divide by negative 7. So x is negative 3. Plug it back into one of the original equations before I multiplied. Okay? So let's use 5x plus 2y equals negative 5. 5x plus 2y equals negative 5. Put in for x. Okay. Perform the multiplication. Now, I need y by itself. Get rid of the 15. Move it over. Okay, so they cancel out, leaving 2y. 15 minus 5 is 10. Divide by 2. Y is 5. So, I'm looking at negative 3, 5 for my solution. Okay? Now, the most complicated ones. Are when you don't have the common factors. Okay? So example 4. If I have 3x plus 4y equals negative 1. And if I have 4x plus 3y equals 2. All right? No multiples, no opposite signs. So I need to look at this. 3 times 4 is 12, 3 times 4 is 12. Now it doesn't matter. I can eliminate either x or y. All the examples we've done so far have eliminated y. This example, I'm going to eliminate x. Since I need a 12 to eliminate, I am going to multiply the top one by 4 and the bottom one by negative 3. When I do this, I will have a positive 12 and a negative 12. Okay? So I distribute 12x plus 16y equals negative 4. Distribute the bottom one. Negative 12x minus 9y equals negative 6. Combine them, because now I have positive and negative, they eliminate. Okay, negative 6, or positive 16 minus 9 is a 7y. And negative 4 plus negative 6, that is a negative 10. Divide by 7. Y is equal to negative 10 over 7. Okay, there's my y. Now, I need to find x. So I have to plug it back into one of the original equations. So now, doesn't matter which one, 3x plus 4y equals negative 1. And we're going to plug y in, so 3x plus 4 times negative 10 over 7 equals negative 1. So 3x minus 40 over 7 equals negative 1. Add the 40 over 7. Okay. Remember, when it comes to the 1, it can be changed into 7 over 7. So you're basically taking 40 minus 7, which is 33. Okay? So now we have to divide by 3. Now, because I have this fraction over here, if I try to divide by 3, it looks confusing. So what I'm going to do instead is I'm going to multiply by the reciprocal. The reciprocal of 3 is 1, because you flip it, right? 3 over 1, so you flip it, make it 1/3. So here I'm going to multiply by 1/3, and I can do the same thing over here. Okay? 3 goes into 33, 11 times, so this is 11 over 7 for x. So my coordinate is 11 over 7, comma, where's my x? Or my y? What do we find for y? Oh, I put it up here. negative 10 seconds. So there's my solution to that system. Okay? So that's elimination method. You have to really look at the problem to determine what you need to do. Okay? If you have different numbers and all positives, you have to figure out which one you want to eliminate. It doesn't matter. Flip a coin if you want. But you need to pick one of the variables to eliminate. And then you have to manipulate the equations to get the same number, opposite signs in front of that variable. Then you can add them. Okay? So that's elimination. Now let's apply it. A catering service placed an order for 8 centerpieces and 5 glasses, and the bill was $106. For the wedding reception, they were short 1 centerpiece and 6 glasses and had to reorder. This order came to $24. Let X represent the cost of 1 centerpiece and let Y represent the cost of 1 glass. Okay. X is going to be the centerpieces. So let's look at where we have centerpieces. We have 8 centerpieces here and 1 centerpiece here. Okay. Then we need to look at the Y part, which is the glasses. So we have 5 glasses and 6 glasses. Okay? There's the information we need to set up our 2 equations. Now, the cool thing about doing substitution and elimination with word problems is usually one sentence has an equation, which makes things a lot easier to find. Okay? So, we have an order for 8 centerpieces. Well, 8x, right? Because x is the centerpiece. And 5 glasses. 5y equals. And then what is the value that we have? $106. So that is equal to 106. Okay? Then the second one. We have 1 centerpiece and 6 glasses. And that equals $24. Okay? There's our system. Now let's solve it. I have 8x and x. I have 5y and 6y. The easier one would be to eliminate the x's. Okay? I can multiply this bottom equation by -8. That'll give me a -8x, so when I add, they eliminate. Okay? So -8x minus 48y equals, let's see here, carry the 3. -192. Okay, let's make sure that that is correct. So 24 times -8 is -192, yes. Okay. Now, bring the top one down underneath. 8x plus 5y equals 106. And add them. The 8's go away. -48 plus 5 is -43y. -92 plus 106 is -86. Okay? Okay, now divide by -43. So y equals there's our y. Now we need to plug it back into one of the original equations to get our x. Okay? I'm going to use the second equation. So I want to use x plus 6y equals 24. Go x plus 6 times 2 equals 24. Okay? So x plus 12 equals 24. Subtract my 12. That's 12 for x. Okay, now this is a coordinate, yes, but we're not going to write it in coordinate form because it's an application problem to a word problem. Okay, application answer. So what do these x and y's mean? Well, x represents the cost of a centerpiece. Okay, and y represents the cost of the glasses. Okay, so our sentence is, it costs $12 per centerpiece. And $2 per glass. Okay? That is our answer. These are the types of questions you're going to get in 3.3. So there it is, elimination. Okay?